Exercise 1014 is asking you to turn this molecule on the left into this molecule on the right. And the first step toward doing that is just to recognize what changed. If you see that and you're like, I have no idea, the first step is just to highlight what changed. So one thing that changed is we have these two chlorines here, and they're on that end carbon, and they're not there anymore. So they disappear. In other words, they're eliminated. So whatever else we know we have to do, we have to eliminate those chlorines, we have to do elimination. Now, another thing you'll notice is that we have two chlorines on the final product, on this carbon, second to last one, that are not there in the beginning. And so whatever else we have to do, we have to add those on. So we have to do addition. So notice, the method, there's this specific problem, and it's good to understand that. But more important than that is to understand the method of solving these problems. The first step is just to look at what changes and to categorize that change in one of our three big categories that we've learned so far: substitution, elimination, or addition. And from there, we can work on what we do first and what the specific recipes are for that. Okay. Well, what do we do first? We know we have to do elimination and addition. Which one do we do first? What we have are two chlorines. Those are leaving groups. That's all you need to do an elimination. You need leaving groups and a base, and you can do elimination. Now, we have two leaving groups, so we could do elimination twice. In other words, instead of just adding a regular skinny base, we can add excess strong base, like sodium amide, followed by water. Now, this is one of the recipes from this chapter, so if that doesn't seem familiar to you, stop the video, go back, memorize all the reactions, and then start playing these videos again. Otherwise, they'll be difficult to follow. So these videos are assuming, from this point on, they're assuming that you've already memorized the reactions. So if we have these two leaving groups, we can do elimination twice. And that will create two pi bonds. Remember, when you eliminate a leaving group, you create a pi bond. Elimination is a way to create pi bonds. So after the first elimination, you would still have those 5 carbons. You would have 1 pi bond and 1 chlorine. After the second, so actually let's just do this so you could see this in real time. So after the first elimination, you create 1 pi bond. After the second elimination, you create a second pi bond. Now we have to redraw this because this is not linear, and these alkynes are linear. So that would really be our product there. Now you might be saying, okay, I understand what the base is doing. What is the water doing? The base would also steal the hydrogen off that terminal alkyne and turn that into a carbon nucleophile, which we don't necessarily want. The water is there to put a hydrogen back on there. You do a proton transfer to stabilize that again. Put the hydrogen back on. So that carbon can act as a base rather than a nucleophile. Okay, well that's what we have after that first step. But that's not what we want. We want this other molecule that has these chlorines on it. So we've done our elimination. What do we do now? Well, we know we still have to do addition. We want to add 2 chlorines. So what do? Well, if we add Cl2, then what we'll get is a double bond. We'll just use 1 pi bond, and we'll have the chlorines add anti to each other. That's halogenation. This is another reaction from this chapter. And if you use excess Cl2, then it'll add again, but we'll end up adding another 2 chlorines. Well, that's not what we want. We only have 2 chlorines here. So we don't want to add Cl2. What's another way we could add chlorines? We could do hydrohalogenation. Now, if we treat this with HCl, that would be Markovnikov addition. That means the H, if we just add 1 equivalent, the H would go on the less substituted carbon, the chlorine would go on the more substituted carbon. And if we treated it with excess HCl, then that would happen again. We would use the second pi bond to stick a second hydrogen on there, and then the chlorine would add on the other position. Well, that is what we want. And so the overall synthesis for this, the change that we need to make is first to use excess sodium amide, followed by water. That is the elimination. It takes these two leaving groups off and creates the triple bond, creates two pi bonds, one for each leaving group that left. And then we have to add these two leaving groups on in a Markov-Nikov way. And notice we didn't just add the chlorines, we also added the hydrogens next door, which are harder to see. But we would add, to do that, we would add excess HCl. And so we see something here that we have seen before. In previous videos in this chapter, we saw how elimination and hydrohalogenation, or halogenation, are sort of the opposite of each other. Elimination takes leaving groups off of a molecule and creates pi bonds. Hydrohalogenation, or halogenation, puts leaving groups on a molecule and takes away pi bonds. So they're really the reverse of each other. And by taking leaving groups off and putting them back on in a different place, you can effectively move them around. And that's what it looks like is happening here. You have the chlorines on the end, and you move them a little bit inward. So this is a multi-step synthesis involving using that strong base, excess sodium amide and water, to create an alkyne, and then using excess HCl, hydrohalogenation, to add two equivalents of chlorine in a Markov-Nikov way.